Good morning. We're going to be looking at parent functions today. And there is a link here to Desmos that'll take you to the function graphs. With that, you're going to log in with your Google account. You're going to label each function and identify the critical points and also find the domain and range for each one. So this first one is called the linear parent function. The equation of it is f of x equals x. This is what the graph looks like. Linear, the first four letters of it spell out the word line, and the graph is actually just a line. The critical points that we're going to look at on this one, these are going to be the ones that we'll use for transformations, are -1, -1, 0, 0, and 1, 1. So on the graph, that would be -1, -1, 0, 0, and 1, 1. The domain of this function is -infinity to infinity. That would be in parentheses. You could also say that if you're speaking it, you could just say it's all real numbers. And the range is the same, also all real numbers. So -infinity to infinity. Second parent function is called the absolute value parent function. That's over here on the right. The equation of this one is f of x equals, and then we've got two vertical bars surrounding an x, and that's read the absolute value of x. The graph of it kind of looks like a V. I found most students have an easier time remembering that because of the V in value. So absolute value makes a V-shaped graph. Now the critical points on this one are -1, 1, 0, 0, and 1, 1. So on the graph, -1, 1 is here, 0, 0 is here, and 1, 1 is there. The domain on this one is also all real numbers, so -infinity to infinity. And the range is all non-negative numbers. So that would be from 0, including 0, up to infinity. The next parent function is called the quadratic parent function. The equation for that one is f of x equals x squared. This is the one you spent a lot of time on in Algebra 1 and also again in Algebra 2. You probably spent a considerable amount of time with quadratics. The critical points on this one are -1, 1, 0, 0. My 0 didn't come out right. There we go. 0, 0, and 1, 1. Got some pen lag going on here. Alrighty. So putting in the points there, -1, 1, 0, 0, and 1, 1. That's the same 3 points that we had for the absolute value function, but the shapes of the graph are very different. So it's important that you get the right shape with those critical points. The domain for this one is also all real numbers, so -infinity to infinity. And the range is all non-negative numbers, just like it was for absolute value. So that would be 0 with a bracket up to infinity. The pen lag is pretty entertaining there. Okay, my next function is called cubic. We talked a little bit about cubic functions when we were talking about the fundamentals unit there, when we're talking about various polynomials. So this is one of those. The equation of that is f of x equals x cubed. It is a third degree polynomial. Critical points on this one are -1, -1, 0, 0, and 1, 1. And I'll plot those also, -1, 1, -1, -1, 0, 0, and 1, 1. So those are the same 3 critical points as there were on the linear parent function over there on the left. But again, the shape of the graph is very different. The domain for this one is -infinity to infinity. And the range is also -infinity to infinity. So all real numbers for domain and range on this one. My next function is called the radical or square root parent function. The equation of that one is f of x equals the square root of x. And the shape of it is like this one over here. If you can kind of imagine, this really is like half of a parabola, half of what the quadratic parent function looks like, but it's also laid on its side. So the critical points on this one are 0, 0, 1, 1, and 4, 2. We'll go ahead and put those on the picture. So 0, 0, 1, 1, and then 4, 2. Domain for this one is all non-negative numbers, so from 0 to infinity, including the 0. And the range is also all non-negative numbers, so from 0 to infinity and including the 0. Our next one is also a radical function, but this one is a cube root. The equation for this one will be f of x equals the cube root of x. Critical points on this one are -1, -1, 0, 0, and 1, 1. So -1, -1 is here, 0, 0 there, and 1, 1 is there. So again, this one has the same 3 critical points as both the linear and the cubic parent functions, but the shape of the graph is very different. This shape kind of looks like the cubic parent function, but again, it's laid on its side. Domain on this one is all real numbers. And the range is also all real numbers. That's a parenthesis. Alrighty, our next parent function is called rational. The rational parent function, the first 5 letters of that word spell out the word ratio. And that kind of tells you a little bit about the equation for this one. The equation on this one is f of x equals 1 over x. So it is a ratio of 1 to x. The critical points on this one are -1, 1, 0, 0, and 1, 1. Sorry, that was -1, -1, 0, 0, and 1, 1. Let's see where those are on the graph, because this one has something that's a little bit different. So -1, -1 is here, 0, 0 is here, and 1, 1 is here. Now what's different about this is 0, 0 is not actually a point that's on our function. The function is made up of these 2 curved pieces here, these 2 branches. And so this point here in the middle is actually the point of intersection of the vertical and the horizontal asymptotes. So there's an asymptote here and there's an asymptote there. Those are like boundary lines. So the graph gets really close to those lines, but it never actually touches them. Our domain for this one is all real numbers except for 0. The way we write that is -infinity to 0, and then also 0 to infinity. And so that would include everything except 0. That's indicated by the parentheses that are on the 0 on either side. The range for this one is also all real numbers except for 0. So I would write the same thing again, -infinity to 0, union, and then 0 to infinity. And again, that says that the 0 is not included because the zeros are encased with parentheses on either side. Our next parent function is called rational squared. So rational squared. So this one is also, oh, it doesn't say that. Inverse squared. Okay, this is rational squared. So again, we have ratio, and it's f of x equals 1 over x squared. So it's the ratio of 1 to x squared. Critical points on this one are -1, 1, 0, 0, and 1, 1. So again, like that last one, this one, if I plot those points, -1, 1 is on the curve of the function. 0, 0 is not on the curve of the function, but 1, 1 is on the curve of the function. So the 0, 0 is actually the point of intersection of the vertical and the horizontal asymptote on this one as well. So there's a vertical asymptote at the y-axis and a horizontal asymptote at the x-axis. Okay, the domain for this one is just like it was for rational, so it's all real numbers except 0. And the range is all positive numbers. So that would be from 0 to infinity. And to say that I want all the positives, I'm going to put parentheses on the 0 also on this one. So this is the difference between all positive numbers and all non-negative numbers. I'm going to go back and look at another graph now. So this one was all positive. That's how we indicate that. If we go back and look at radical, the square root, this one was all non-negative. And so the difference is kind of subtle. This one just has a bracket on it instead of a parenthesis, but that means that the 0 is included on this one. 0 is included as a y value. Whereas on this one, the 0 is not included as a y value. Our next one is called exponential. Okay, the exponential function is f of x equals b to the power x. And for this particular one that we're looking at, this is going to be with a b value that is something greater than 1. So the b has to be a number bigger than 1. So like it could be 2, or it could be 3, or it could be even 1.5 or 1.1. But it can't be a fraction, and it definitely cannot be negative. So our critical points on this one are -1, 1 over b, (0, 1), and 1b. So for the picture here, I want to say that the b value, we're going to call it 2. And so on the graph, this critical point would be at -1, 1 over 2. So -1, 1/2 would be right there. 0, 1. That one stays no matter what the value of b is. And then the other one is 1b, and the b value is 2. So this would be at 1, 2. So this particular graph would be f of x equals 2 to the power x. And it makes this shape because this value, this base, is bigger than 1. Okay, the domain of this one is all real numbers. So -infinity to infinity. And the range is all positive numbers. So again, that would be 0 to infinity. And because I only want the positives, that would be a parenthesis on the 0. So it does not include the 0. Our next one is logarithm function. For short, we call it log. The equation of this one is f of x equals log base b of x. So log base b of x. And once again, on this one, the b value does have to be greater than 1. So our critical points on this one is actually just taking the critical points from your exponential and reversing the order. So for this point, instead of -1, 1 over b, we would have 1 over b, -1. And for the next one, 0, 1, switch the x and the y, so we get 1, 0. And the third critical point would be 1b switched would give me b1. And once again, on this one, this is actually f of x equals log base 2 of x. So my b value on this one is 2. That's a 2. There we go. So when I go to plot these critical points, 1 over b would be 1/2, and then -1. So that would be this point right here. 1, 0 is here, and 2, 1 would be right there. Domain on this one is all positive numbers, so from 0 to infinity. And the range would be all real numbers, so -infinity to infinity. Now these two functions, exponential and logarithm, are very closely related. They're what we call inverses of one another. And the way you get from one function to its inverse is you just switch the x and the y for everything. So in effect, that actually changes your domain and range also. Since the domain is all your x values and the range is all your y values, when you take the inverse, switching the x and the y, the range for this one tells you the domain for that one, and vice versa. Domain for this one tells you the range of that one. Okay, 2 more. This next one is called a step function. And the equation for this is f of x equals, and then this is kind of a funny symbol here. Oops. It's not quite that funny though. That did not come out right at all. Let me try that again. Okay, so it is a bracket with 2 bars on it, and then an x, and then there's a closed bracket here again with 2 bars on it. And it's called a step function because it looks like stairs, essentially. It's just a bunch of little horizontal lines. Critical points on this one. We actually don't have any, so we're going to leave those off. The domain for this one is from -infinity to infinity. And the range for this one is kind of funny. If we're looking at the graph, the y values that we have on this one are only integers. So this one corresponds to a -5, this one's a -4, this is a -3, -2, -1, 0, 1, 2, 3, 4. So it doesn't include all of the numbers in between. It's just including those particular values. And it does go on forever. This is just giving us the pattern for that. So it does go on forever. So the way I'm going to indicate that is I have to use a different kind of notation here. I'm going to use a curled brace. I'm going to put ... And then I'm going to list a few of the numbers enough for us to see the pattern. So I'll say like -2, -1, 0, 1, 2, and then another ... to say that the pattern continues that way. And then our last function, our last parent function is called constant. The constant parent function is just f of x equals c. We use the word c for constant. The graph of that one looks like just a horizontal line. Now critical points on that would be -1c, 0c, and 1c. So in this particular graph, our c value is 2. So the equation that we're actually graphing here is f of x equals 2. And so if I wanted to plot these 3 points on here, I would have -1, 2, 0, 2, and 1, 2. So all fall on the line. They're all on a horizontal there. So the domain for this one is all real numbers. X can be anything. Oops. Sorry, I started writing that in the wrong notation. So this would be -infinity to infinity. And the range on this one is just a single value. For this particular graph that we have, that particular value is 2. But in general, we would say that that particular value is c. So I'm going to use this notation for this one. And this time I don't have to do a ... I can, it's just that one value. So there's no pattern there. It's just c.